Welcome again to my YouTube channel. Let's see how we can answer this problem on KIRCHOFs. This is a closed circuit diagram. Remember, KIRCHOFs describe the relationship among current, potential difference, and electromotive force, EMF, in a given closed circuit. So, for us to solve this question, to get the currents flowing in this closed circuit, let's first take any direction of our choice as the direction of current and direction of loop. I take this direction, I take this direction. You take this direction such that some of them will be moving into a junction while some will not be moving into this junction. That is, this and this are moving into the junction, whereas this one is moving away from the junction. But if you take it such that all of them will be moving, let's say you put this arrow like this, the implication is that all of them are moving into the junction. That would be a wrong direction. So while drawing it, make sure that some are moving away from the junction, whereas some are moving into the junction. Once we are done with that, we can take direction of loop as we want. I take my own to go this way, and I take this one to go this way. Okay? Someone can say, let him take it this way, opposite way. Whichever one you do, you are correct. But when you are done with your calculation, the answer you get will help you to know the exact direction you will have for that circuit diagram. Okay? Now, we want to see how we will resolve this. Let's label the circuit. We'll call this resistor R1. We'll call this one R2. We'll call this one R3. And we'll call this one R4. Okay? Now, first thing you do is you call this loop A and loop B. Then next thing you now do is you apply KIRCHOF's first law. I repeat, apply KIRCHOF's first law. KIRCHOF's first law is called Junction Rule or current rule. KIRCHOF's first law is called Junction Rule or current rule. That is, the rule states that sum of current moving into a junction is equal to sum of current moving away from the junction. What do I mean? This current I1, this one I1 also, because this current will meet this to enter here. So it is same current that is here that is also here, because it will move from this resistor, get to this, because they are in series. Whenever two resistors are in series, they will have same current. So this is I1, this is I1. So this is moving into the circuit. This is I2, while this is I3. Okay, now the I1, current I1 plus current I2 will be giving you equals to current I3 because it will move. So here is your I3. The current that this one have is your I3. Okay? So what you now do is you say I3. This rule is first rule. We'll call it junction rule. Okay? This rule says that these two currents moving into this junction is equal to this current that is moving away. I1 and I2 are moving into the junction, whereas I3 are moving away. Okay? So what you now do, after you have written this first rule, after you have represented it mathematically, remember that this first KIRCHOF's rule explains principle of conservation of charges. Yes, this means that at no junction will charges be created or destroyed. That is to say that when you take the algebraic sum of all the current in the circuit, this coming here will be minus I3, or will be giving you 0. So it talks about conservation of charges. Now, once you are done with this, next thing you do is you go for the second rule, which we called the loop rule. The loop rule or the voltage rule. Now, what did this rule talk about? It said that algebraic sum of potential differences of different circuit elements of a closed circuit is 0. I repeat, the rule said that algebraic sum of potential differences of different circuit elements of a closed circuit is 0. And this rule is based on conservation of energy. Okay? Now, see what it says. The rule says that summation of electromotive force minus summation of all will be giving you 0. That is how to represent it. Now, it is important to note that when current is moving in same direction with the loop, it means that the current will be assigned a negative sign. Look at this. This is moving this way. This is moving this way. Then the loop is also moving in that direction. Okay? It means that from loop A, we'll be having this one, and this is moving in the same direction. We'll have minus I1 times 1. That is the resistor. Then this is moving up. The I1 here, which is this current, is moving in the same direction with this. So we now say that since it's moving in the same direction with this, we say minus I1 times the resistor it has. Then look at this. This is moving down while the current here is moving up. This is moving down and this is moving up. We say it will be plus because if the direction of the loop and the current are in the same direction, the current will be having negative sign. But if the direction of the loop and the current is in different direction or opposite, the current will be having positive. We say plus I2 times resistor 3 ohms. So now watch this. As it comes to this, it means that this is negative terminal of the battery or cell, and this is positive terminal of it. So this loop moving this way means it's moving from negative terminal to positive. And once it's moving that way, it means that the voltage will be equal to positive sign plus 2. But if it moves from positive to negative terminal, the voltage will be minus 2. So we note it as what happened in loop A. Okay? Then we come again, we say in loop B, what happens there is that for this current I2 and this are in opposite direction. So we'll be having plus I2 bracket 3 because they are in opposite direction. This is moving up while this is moving down. Then this and this are in opposite direction also. We say plus I3 bracket 4 because this current you see is owned by this resistor. Okay, so what you now do is you say is equal to, you compare it with the voltage you have here. You say it's moving from, this is positive terminal of the cell, this negative terminal of the cell. It moves from negative to positive. So you say is equals to 4. Okay, so note that once the loop is moving from, direction of the loop move from negative terminal of the cell or the battery to the what? Positive, you say it will have positive sign. The voltage will be positive or the EMF will be positive. Whereas if it's moving from positive to what? Negative, you say is equal to minus 4. Now, we have derived a lot of equations and we need to sort them out. We say, therefore, we have here that I3 is equal to I1 plus I2. Equation 1. So here we have it that minus I1 minus 2I1 plus I2 equal to 2. Now, minus I1 minus 2I1 will be giving you what? Minus 3I1. Then plus 3I2 equal to 2. You say, therefore, you'll be having minus 3I1 plus 3I2 equal to what? 2. Okay? So, what you now do is, you now bring this one down also. It will give you 3I2 plus 4I3 equal to what? 4. Okay? So, we now say what is the equivalence of I3. I3 is this in equation 1. We'll carry it and put it here. That will be giving you, therefore, 3I2 bracket plus 4 bracket I1 plus I2 equals to 4. So what you now do again is you multiply out 3I2 plus 4I1 plus 4I2 equals to what? 4. This plus this will be giving us 7I2 plus 4I1 equals to 4. Then we link it to this one, this top one. So this is equation 1. Then this one is 3I2. Rewriting it, we have minus 3I1 equals to 2. Now you solve this simultaneously. Solving it simultaneously will give you that 3 times is 21I2, 3 times is plus 12I1 equals to 12. This times is 21I2, this times is minus 21I1 equal to 14. You subtract. This minus this will go. So this will give you 33I1, because minus times minus will give you plus, equal to what? 12 minus this, that will be giving you minus 2. Therefore, I1 is equal to minus 2 over 33. Okay? So we'll be able to get our I1. Okay? We now say to get our I2, what do we do? This is I1. You put it here. You say from equation 2, that is this equation, we have 3I2 minus 3I1 equals to 2. Okay? And I1 is minus 2 over 3. You now say 3I2 minus 3 bracket minus 2 over 33 equals to 2. That will be giving you plus 6 over 33, or yes, equal to 2. 3I2 equal to this. Then 3I2 equals to 2 minus 6 over 33. Okay? That will be giving you 60. This is over 1. LCM is 33. 1 divide 33 is 33 times 66 minus 6 all over 33. Okay? Equal to 3I2. Therefore, 3I2 is equal to 60 over 33. 3 here, 20, 3 here, 11. and is equals to 3I2 equal to 20 over 11. I2 equal to 20 over 33. Okay? Then we have gotten our I1 and our I2. We need to get our I3. We says from equation here, I3 is equal to I1 plus I2. Therefore, what is our I1? I1 is minus 2 over 33 plus I2 20 over 33. That will be giving you 33. Minus 2 plus 20 will give you 18. 3 here, 6. 3 here, 11. Therefore, I2 equal to 6 over 11. You said, therefore, we have gotten our currents to be I1 equals to minus 2 over 33. I2 equals to 20 over 11. I3 equal to 6 over what? I3 equal to 6 over 11. So, we said we have gotten our currents. Now, after you have gotten your current, if your final current is positive, like this one, I2 is positive, I3 is positive, it means that the direction of the current for I2 is okay. It means that the correct direction of current for I2 is okay, I3 is okay because they are positive. But for this I1 that is negative, when you have it to be negative, it means that the direction we took as our I1 is not what it's supposed to be. I1 is supposed to give you opposite direction. It's supposed to. So we put the direction this way. We'll sketch it here. This is direction of current for I1. It will change. I1 direction will change to opposite of what we have. Here is this direction. So it will give you this because of negative. Then this will maintain its direction. Then this will also maintain its direction. Now, the loop will also change its direction so as to see that at the end, this and this will be giving you negative, because once the direction of the current is same with direction of the loop, it will give you a negative answer. Okay, so that is it. So what you now do is, since we have been able to resolve this one, the loop direction will remain as it is because this is positive, I3 is positive, and I2 is positive. So their direction will remain as it is. So this one is loop A, loop B. So the direction of this will move this way to make sure that it will give you negative, because the negative sign says we are to change this direction to opposite of it. Okay, and also make sure that the loop will also correspond with the current so as to give you negative. Okay, then I3 retain its direction, I2 will retain its direction. Okay, so that is how to solve questions on KIRCHOF's rule. Remember, we say it describes the relationship between current, voltage, and electromotive force. Enjoy other videos we have in this channel. See you next time as we upload more videos on this. As you enjoy it, click like button, click subscribe, and turn on your notifications so that you get notified as we post more videos on our channel. Thanks for watching the video.